Okay, so what we're going to be learning about today is molarity and molar concentration. So these things are two of the same things. And what we can see from them, I'll give you the units for each of them. Molarity, the units is written out as a capital M. So remember that's the units, okay? That's not the variable. So these are the units, capital M. The units for molar concentration are moles per liter. Okay. So those are the two of the same things. They're just different words for them. So if we refer to it as molarity, that means molar concentration or concentration. All these things mean the exact same thing. So what we have for concentration, we have a whole new calculation, and that calculation is C equals N over V. So C equals N over V. You've seen two of these variables before already. N is just moles, and units is moles, right? Moles are something we've talked about a couple times already before, and then V is volume, which the units for that is liters. So if we look at our formula, we have C equals N over V, our concentration equals moles over liters, and our units for concentration are right there, moles per liter. Okay, so that's the first part breakdown. That's what concentration is. The units should for N, we don't have really anything else. They should always be in moles. Volume should always be in liters, and then concentration will be moles per liter for Chem 20 and what we need to do. So let's look at our first example there. How this works. So what is the concentration of a solution in which 1.5 moles of copper 2 sulfate is dissolved in water to make 2 liters of solution? So same thing we do for all our calculations. We write out what we know. We know what is the concentration. So that's our unknown. C is our question mark. In a solution which 1.5 liters, we have our N value, which is, 1.50 moles, not liters. So we have 1.50 moles as our number of moles, and then we have a volume of 2.00 liters. So to find the concentration, we use our formula, C equals N over V. We take our variables, we got N, which is 1.50 moles, over the volume of 2.00 liters, and we get a concentration calculation of 0.750 moles per liter. So that's our concentration. We got to specify what our substance is, and we have copper 2 sulfate is our substance. And there's our calculation for concentration. Pretty straightforward. So that's an easy one. Nothing more to it. That's just a one-step concentration calculation. And we'll go to the next one here, which has a multi-step, which gives us a little more options of things to do. Okay, so this is example number 2. A given sample of household ammonia contains 156 grams of NH3 dissolved in water to form 2 liters of solution. So we know a couple things from that. We know our mass, which is 156 grams, and we know the compound is ammonia, which is NH3. We know that the volume is 2.00 liters, and we're looking for the concentration, which is C. Okay, so this is what's given to us. And if we quickly look at it, we say, okay, we're looking for concentration, which is N over V. We look at what we have. We have V. We do not have N. We have mass. Okay, so mass is not what we need, but we know how to find moles from mass. We just need to include our molar mass. Okay. So molar mass for ammonia, if you calculate it out, you do the math, you get a molar mass of 17.04 grams per mole. Okay, and here's what comes up there. Now that we have that, and I know I talked to this about the beginning at the beginning of the course, this molar mass calculation comes up a lot, and it'll be very easy by the end of this course. So mass over molar mass is the first thing we do. So that's our first step. We find the number of moles. So we have 156 grams. 156 grams divided by 17.04 grams per mole. And then we get an N value of moles of 9.1549 moles. And our compound is NH3, just so we keep track of that. Now that we have our N value, we can go to our second step, and that's actually calculating the concentration. C equals N over V. We have 9.1549 moles of NH3. So that's what we just found down here, and we brought it up to this new calculation here. And we divide by our volume of 2.00 liters. So our concentration is now going to be 4.58 moles per liter of NH3. And that is what we just solved for, that concentration. Okay, so again, pretty straightforward calculations. You know how to do moles from mass and molar mass. That's our first step. We use that number that we found and use it in our second calculation to find the concentration. A couple different ways you can do this. One being this way, where you do step by step. Next one, I'll do unit analysis here. So unit analysis, we just know what we're looking for. We're looking for the concentration of NH3. Concentration of NH3. Okay, so we start with what we know. We know that we have 156 grams. Why do I keep on forgetting that 6 is the big question? Of NH3, and we're going to multiply that times, this is unit analysis. We're going to figure out how do we get rid of that grams. Well, we can use our molar mass and to eliminate that grams, right? Grams is on the top of this fraction. This is over 1. So if we have a 17.04 grams of NH3 over 1 mole of NH3, well, we can quickly go through and we can get rid of our grams here. Now we have moles of NH3. Then, well, we're looking for concentration. Units for concentration is moles per liter. So if we have moles on the top, we just want to now divide by liters. We put it over 1 because we don't have a unit on the top. We want to keep this unit as it is. Have our unit there of liters. And if we look through, we got rid of grams. We're left with moles per liter of NH3. And now we just do the math. You do 156 divided by 1, you get the same thing. So it's 156 times 1 divided by 17.04 times 1 divided by 2. And you're going to get the same number of 4.58 moles per liter of NH3. So that's just, we can see you got the same answer. This is unit analysis. Again, same as stoichiometry, you can do step by step, or you can do the unit analysis and you get the exact same thing. One last thing I'm going to show you, another way of looking at it. I just got to erase my page here. Okay, so we know our answer is 458 moles per liter. So people who've taken physics before know that they can start manipulating formulas and putting formulas together. So here's how you can do that with this. Sorry, bear in my time. They didn't give us an eraser in this app. Okay, so last thing, or one more thing. So one more way of looking at it is you can look at our formula is C equals N over V. So C equals N over V can be our formula. We also have our formula as N equals mass over molar mass. So what you can do here is you can take this n value and substitute this mass over molar mass into this formula. So this formula, if we substitute this into here, becomes C equals mass over molar mass. So that's all the top. And we divide by volume. We can rearrange this and know that more mass goes to the bottom. So our formula becomes concentration equals mass over molar mass times volume. So you can use this as well. You just either have to derive it or write it out. But if you do this out, you can just plug in your values that we have here. We have mass, you have volume, you have molar mass. You can solve for concentration all in one step. So